Hi, I'm Chris Teutsch, Forage Extension Specialist at the University of Kentucky's Research and Education Center in Princeton. And this is part 4 of hay quality, defining, quantifying, and supplementing. In this part, we're going to look at factors that impact hay quality. And there are a number of factors. The first is species. So in general, legumes tend to be higher in forage quality than grasses. Life cycle is a second factor that can impact forage quality, and annuals tend to be higher in quality than perennials. The photosynthetic pathway can also impact forage quality, with cool season grasses being higher in forage quality than warm season grasses. The temperature under which the forage has been grown also impacts forage quality. Generally speaking, as temperature increases, forage quality decreases due to greater amounts of lignin in the plant fiber, which makes it less digestible in the rumen of the animal. Fertilization directly impacts yield and, to a lesser extent, crude protein. It has a limited impact on plant fiber, though. The time of day that we harvest forage plants can also impact forage quality. Generally speaking, after the plant has gone through photosynthesis all day long, harvesting in late afternoon will result in higher concentrations of sugars and carbohydrates in the plant. That doesn't mean in the humid eastern United States that we should be waiting till late afternoon to harvest our forage. In the humid eastern United States, we have a limited window for curing that forage. So it's important to go ahead and maximize the drying days by harvesting as soon as the dew gets off of the forage in the morning. Stage of maturity can impact forage quality, with vegetative forage being more digestible and higher in forage quality than reproductive tissue. Conditions during harvesting, such as rain, can also impact forage quality. Rain has a greater impact on forage quality as the forage dries out and we get closer to actually making it as dry hay. If it rains when the forage has just been cut, the impact of the rain will be fairly limited. If it rains when the forage is almost dry enough to bale, then we tend to have higher losses. And then how we store that hay can impact forage quality. There's two that I want to focus in on today, and the first is fertilization, and the second is stage of maturity at harvest. Soil fertility directly impacts stand productivity and persistence. It directly impacts forage quality to a lesser extent, and the most important parameter that it impacts is crude protein. And it kind of has a mixed effect on fiber. And that's kind of what these graphs show here. So crude protein, as we increase nitrogen fertilization, we see we get a increase in response in crude protein. Plant fiber in these second two is kind of a mixed bag. One of the important roles of having good soil fertility is creating an environment that allows legumes to be persistent and competitive in stands with grasses. Legumes are an important part of grassland ecosystems. Nitrogen fixation is the second most important biochemical process on Earth after photosynthesis. And that's why legumes are keystone species in grassland ecosystems. Legumes improve soil fertility and structure. They reduce water and air pollution, improve the yield of grasslands, improve forage quality and animal performance, mitigate tall fescue toxicosis, which is a really important role of legumes in the transition zone of the United States, where tall fescues are dominant forage species. And they improve the overall economic and environmental sustainability of forage livestock systems. The first thing we need to do when we talk about soil fertility is to soil sample our pastures. It's hard to manage something that we don't measure. So soil testing quantifies things like soil pH, phosphorus, and potash, not nitrogen. Nitrogen is a very mobile nutrient within the system. So it provides us baseline data upon which we can start to manage a soil fertility program. It's most important when fertilizer prices are high because it allows us to target fertilizer applications and apply only what we need and not what we don't need. We have a really nice publication on soil sampling, hayfields and pastures, and it just kind of reminds you of how to get a good soil sample. The results of a soil test are only as good as they are representative of the pasture or hayfield that we're trying to measure. You can access this publication by clicking on this QR code or Googling UKY AGR 252. Okay, when we get our results back, one of the most important things we can do is apply lime according to our soil test results. Soil acidity is still a major factor in limiting forage production in the southeastern United States. It reduces nutrient availability and reduces nitrogen fixation in our legumes. And this is the impact that soil pH has on nutrient availability in the soil. Each one of these bars are different nutrients. The wider the bar, the more plant available that nutrient is. On the left-hand side of the graph, over here we have an acid soil, over here we have an alkaline soil. When we're in the ideal pH range, which is going to be 6 to 7 for most of our forages, we maximize the availability of all of our major nutrients like nitrogen, phosphorus, potassium, sulfur, calcium, and magnesium. Liming neutralizes soil acidity and supplies calcium and magnesium. These are some general guidelines. In most cases, for hayfields that contain a grass-clover mixture, if we're between 6 and 6.4, we're in pretty good shape. If we have a grass-alfalfa mixture, then we want to be 6.5 to 6.8. Now, there's a number of products that you'll see on Facebook, and this is one of those products that's marketed pretty hard towards forage and livestock producers. It's marketed by a company called Agritech, and their ads say things like raise pH fast, cheaper than lime. And they have lots of testimonials, and that's always a red flag for me. If they have no data but lots of testimonials, then you should really take a hard look at that product to see if what they're promising you is true. So we did a little field study to evaluate liquid calcium, or ProCal, from Agritech, Ag Limestone, and pelleted limestone to see how effective they were as liming materials. And we did this replicative study at 16 locations across the Commonwealth of Kentucky. This was the soil pH at the start of the study, and this was averaged over all 16 locations. As you can see, there was no difference in soil pH at the start of the study for any of the treatments. We had a control treatment. That means it had nothing applied to it. A liquid calcium treatment, or ProCal, applied at the highest labeled rate of 5 gallons per acre. A pelleted lime and an ag lime applied at 2 tons per acre, adjusted for relative neutralizing value. This is 12 months after application, and we had a couple measurements with between application and 12 months, but for time's sake today, I'm just going to show you the 12-month data. So if we look at the control, so that's where no lime was applied, liquid calcium, 12 months after application of liquid calcium, we had no change in soil pH. If you contrast that to pelleted limestone and ag limestone, we had a significant increase in soil pH. So we moved from below 6 to about 6.5 in 12 months after the application of pelleted lime and ag lime. So what's this telling us? It's telling us that liquid calcium does not adjust soil pH. And if you're interested in learning more about this study, you can go ahead and look it up on our YouTube channel, and you can reach that by either Googling KY Forage's YouTube or scanning that barcode, and it should take you to the video. The video is entitled Liquid Calcium Boon or Boondoggle. I don't want to ruin it for you, but I'm going to have to go with boondoggle. Okay, so we get our soil test results back. If we need phosphorus and potassium, we need to go ahead and apply that according to soil test. What we want to do is maintain our soil fertility in the medium to medium plus range for both phosphorus and potassium. And if we do that, we may give up a little bit of yield towards the bottom of the medium range, but in general, we're going to be giving up a limited amount of yield. We want to monitor soil fertility in our hay fields closely. Nutrient removal is much higher in a hay production system than in a pasture system. In a pasture system, most of the nutrients are recycled through dung and urine. In a hay system, we're removing a tremendous amount of nutrients. If we look at orchard grass, for example, we remove about 36 pounds of nitrogen, 15 pounds of P2O5, and 55 pounds of K2O per ton of forage. So if I have a good year and I make 3-ton yield, all of a sudden we're removing 45 pounds of P2O5 and 165 pounds of K2O per acre. If we don't return those nutrients, we will draw the levels of soil available phosphorus and potassium down significantly over time. And that will result in poor stand persistence and poor productivity of that stand. I can almost always tell you when I look at a soil test report whether it's a hayfield or not, because we're usually short on potassium in most cases. So it's important to remember just to apply fertilizer when soil test values drop below the mid-medium range. I'd like to take just a minute and show you a little bit of data on a fall fertilization study that we conducted at the research station in Princeton. And what we did was apply late fall nitrogen, so after Thanksgiving. Fall fertilization is a practice that's been pretty standard in the turf grass industry for a long time, and Street and co-authors reviewed it in an extension publication from the Ohio State University. What we did at the research station was take a tall fescue hayfield and apply the following treatments to it. So plots in this tall fescue hayfield received nitrogen as urea in one of 3 treatment groups. Either a fall application, and that would be after Thanksgiving, so the beginning of December, a spring application, late March or early April, and then fall and spring. So they received the nitrogen on both dates. And the nitrogen rates were 0, 40, 80, or 120 pounds of nitrogen applied in the spring, or 0, 40, or 80 pounds of nitrogen applied in the fall. And this was the results. Let me just take a minute and tell you how these graphs are set up. So this first graph is 2023. The second graph is the second year of the study, 2024, when it was repeated. This is the yield on the y-axis, nitrogen rate on the x-axis. 2 lines, a solid line is the fall nitrogen application. This dotted line is the spring nitrogen application. So what we did was when we looked at the 80-pound rate applied in the fall, and we kind of extend that line out till it intersects the spring line, what we found was that 80 pounds of fall-applied nitrogen was as effective as 100 to 120 pounds of spring-applied nitrogen. Pretty interesting. My initial thoughts were that when we applied late fall nitrogen, we would lose a lot of that nitrogen from the system. But the tall fescue is not completely dormant even as we get into the beginning of December. So it sequesters or grabs that nitrogen and stores it in the root system of the plant. And that does several things. It gets that plant ready to grow in the spring by producing more tillers and increasing carbohydrate storage in the plant. And then when the time comes in the spring, plots that received fall applied nitrogen greened up earlier, had more early growth, and had growth that was equivalent to 100 to 120 pounds of nitrogen applied in late March or early April. The second factor that impacts forage quality that I wanted to mention was stage of maturity at harvest. And this is the single most important factor impacting forage quality, hands down. So if you can do one thing to improve your hay quality, it's going to be harvesting at the proper stage of maturity. And that's what this diagram is showing. This is a diagram from Dr. Blazer at Virginia Tech. And what it shows is we go from a leafy vegetative plant to one that's at full bloom, producing seed. The digestibility and the intake decrease, but the yield increases. So where we want to be at is kind of where those two lines cross at. That's a good compromise between yield and forage quality. Unfortunately, a lot of times harvest will get delayed and will tend to maximize yield, but forage quality really suffers. If you think about one graph when you're driving home tonight, think about this table on the effective stage of maturity of tall fescue hay on forage quality and animal gain. So as we go from a late boot to reproductive stage where the seed's forming, we go from about 14% crude protein to about 7.5% crude protein. Digestibility also decreases from about 68% digestible to 56% digestible. And dry matter intake as pounds of dry matter that the animal can eat per day goes from 13 to 8.6. So think about that. So we're not only decreasing the quality of the forage, the animal can eat less of that lower quality forage. So it's kind of like a double whammy on the animal. And when we look at animal performance, we decrease from 1.4 pounds to 0.4 pounds, so we lose a pound of animal performance per day in these steers just due to the stage of maturity when that hay was harvested. That's pretty important to understand. If we can do one thing to improve hay quality on our farm, that's cutting at the correct stage of maturity. Okay, that's the end of this section. And we'll be moving on to the next section now.